Hello and very welcome back to our channel again. And as you might be aware, we have been discussing several analog circuitry and so many other physics topics as well. This time we have brought to you on your screen a digital logic element that we want to understand how this digital logic or digital circuit will work. So as many of you must be guessing what kind of digital logic or digital block this is. So let me tell you, this is a multiplexer unit. And this is a very commonly used digital logic or digital block in digital system design for data transfer. So you got basically the inputs. Let me annotate here as well. Here, this side you have inputs and here you have an output. And there are types of multiplexers available. For example, you can have 2:1 mux, you can have 4:1 mux, you can have 16:1 mux. So in another word, multiplexer is also known as many into one. Many into one. What does it mean? So you've got many inputs and with that you have got this mux inside and you have an output, but output will be only one. Okay, and based on the selection line or the control, select or control here, you choose which of this line gets connected to the output. So whatever the data in digital is either 0 or 1 that gets connected to the output line. So it's basically a switch. That's why you got many inputs on which the data in the form of 0 or 1 is available. And based on this control, your circuit switches and connects a single input out of n inputs to the output line. So it's a kind of data transfer unit commonly used in digital logic design. So this block will be called as n:1 multiplexer. Let's focus on our topic, which is the problem that is given here. So as you can see that it has got 4 inputs, A0, A1, A2, and A3. And that is called 0, 1, 2, 3. So 4 input lines. And on each of these input lines, the data available will be 0 or 1, 0 or 1, 0 or 1, and 0 or 1. And you've got two select lines. So obviously S1 and S0 are the two select lines, and the external control is denoted by letter C and letter D. So obviously there are 4, since it's a binary system, because there are 2 bits, 0 and 1, you can have 4 possible combination as given by this equation, 2 to the power n. And out of the select lines, you have n equals to 2, that is for the select lines, and therefore 2 to the power n, which is 2 to the power 2, equal to 4 select combination. I want to say select line combination here, combinations. So it means you will have the logic elements like S1, then you have got S0, and there are 4 possible combination based on which we will decide, this mux will decide which input line out of A0 to A3 to be connected to the output here. So 0, 0, 0, 1, 1, 0, and 1, 1. Okay, will be the 4 select lines. And based on that, you have got the output. Let's call the output is Y here, and we'll see now. So for the 0, 0, you have A naught getting connected to the output Y. For the 0, 1, you have A1 to be connected to the output. For 1, 0, you have A2 to be connected to the output. And for 1, 1 possible combination of select lines, S1, S0, you will have A3. Remember, your S1 and S0 are essentially input C and input D, which are externally denoted right here. Okay, so now there is one question that is asked to be solved here. So here's they say, consider it is 2-bit multiplexer. Why is called a 2-bit multiplexer? Because you have got two select lines. So here I would say n equal to 2, where n is the number of select lines. Or rather, I would say you can call it like m equal to 2, because n here we have selected to be the number of inputs actually. Okay, so m equal to 2. Here also you can say m, here also you can say m, here also you can say m. Okay, and next line says the for output to be XOR of C and D. So when we say XOR of C and D, what should be the values of all these 4 inputs? That's the question. So in order for the output Y, that has to be C XOR D. We can write C, this is the symbol of XOR D. And the logic equation for that is C bar D or C D bar. This is what we want. And if we want this, then the question here is A0 to A1 to A2 to A3. What should be the values? Whether they should be 0 or 1, so that we finally will have such output. So how to solve this question? To solve this question, we first need to write the logic equation for the Boolean expression for this based on this truth table for this multiplexer, which is 2:1. We will write the Y in terms of C and D, right? So what is C? Here it is S1 and D. So we first see the combination of 0, 0. So here we'll write C bar, D bar, A naught. This is the one output when C bar and D bar. C bar and D bar is logic 0 plus C bar D A1. That is the second combination. C is 0 and D is 1. That's why C bar D. Or C D bar A2. That is the second combination here. The first, second, and third. And finally, or we want C D A3. So output is logic high when either of these terms, number 1 term, number 2 term, number 3 term, or number 4 term is true or is turned out, that turns out to be 1. Okay, so if any one of these terms is logic high, then the output is high. So this is basically or combination, this or this or this or this. But now we have to solve this puzzle here. He says output should be C bar D plus C D bar, which is basically an XOR logic. For that, what should be the values of the inputs from A0 to A3 so that the Y will turn out to be like this. So let us solve this. So obviously, we know that if we can set A0 to be 0, obviously this term gets cancelled. A1, so let me write here, A0 should be 0. Okay, I will place these input values right here in the block diagram. Okay, and A1, what, it's very simple. I just want these two terms, C bar D and C D bar. So I will see where these terms are here. C bar D and C D bar, these two terms I want in the equation. This I don't want. So obviously A naught and A3 is set to be 0, and A1 and A2 is set to be 1. So if I have this combination, I will get to this answer. So that's how we will solve this question for the 2-bit multiplexer as shown in this figure. For the output to be XOR of C and D, the values right here for the inputs should be what I have shown you here. This is the answer, and this is how the logic equation. So this is basically an XOR logic where Y is basically C bar D or C D bar, and your inputs, this is like Y equal to this. So inputs are CD right here, and this is your logic symbol for XOR gate. Okay, so hope you understand this question for the digital logic design. And if you understood that, click the like button, share this video with others for a wider reach, and stay tuned for more engaging contents on the digital logic now as well. Till then, wish you happy learning.